In this video, I want to provide the solution to the Integral Online Test T2, question 3. So in this question, we are given a sector of a circle, and we're told its perimeter and its area. So we have an area of 48 centimeters squared and a perimeter of 28 centimeters. So let's draw out a sector of a circle. Let's think about what we know. We know the area of this sector. We don't know the value of theta here. And we also don't know the radius. And be careful because we don't know the arc length, because this says perimeter, not arc length. But what do we know? We know that the area, which is equal to a half r squared theta, is equal to 48 centimeters squared. And the perimeter, which is the total distance around this sector, is equal to r plus r, so 2r, plus the arc length, which is r theta. And that is equal to 28. And what we have here are two simultaneous equations. We have equation 1 and equation 2. And we need to solve these simultaneous equations. Well, there's lots of different ways of doing this, but given that we are asked to find r, I'm going to eliminate theta. And in particular, I'm going to take equation 2 and I'm going to make theta the subject. So if we take equation 2 and we subtract 2r from both sides, we get 28 minus 2r. And then if we divide both sides by r, theta is equal to 28, subtract 2r over r. And now I'm going to substitute this. So this is my equation 2. I'm going to substitute into equation 1. So we get a half r squared times by 28 minus 2r over r is equal to 48. And this is an equation in r that we can solve. Let's do a little bit of simplifying. We can cancel a factor of r squared divided by r is r, and then we have 28 minus 2r all over 2 equals 48. And actually there's a common factor of 2 here, so we have r 14 minus r is equal to 48. Expanding this out, we can see we have a quadratic equation. So 14r minus r squared is equal to 48. And then collecting all the terms on the right hand side, 0 equals r squared minus 14r plus 48. And if we look carefully, this does factorise, so we have 0 equals r minus 8, r minus 6. So our two possible values of r are 6 and 8. And be a bit careful, because it asks you to make sure you put the smaller one in first, so you need to put those in the order 6 and 8. That is all you need to do to complete the question, but given we have simultaneous equations, we might as well verify we've got them correct. So I'm going to take my two values of r and I'm going to substitute them into equation 2 to find theta. So when r equals 6, theta equals 28 minus 2 times 6, so 28 minus 12 over r, which is 6, which is 16 over 6, which is 8 over 3. And then we can verify that this does in fact satisfy our original equation 1. So verify in 1, well, a half times r squared, which is 6 squared, times theta, which is 8 over 3, is equal to a half times 36 times 8 over 3. Well, 36 divided by 3 is 12, 8 divided by 2 is 4, so this is 12 times 4, which is 48, as required. Similarly, let's verify when r equals 8. So when r equals 8, theta equals 28 minus 16 over 8, which is 12 over 8, which is 3 over 2. And then we verify in 1, a half times 8 squared times 3 over 2 is equal to a half times 64 times 3 over 2. Well, 64 divided by 4 is 16, so this is 16 times 3, which is also equal to 48. So we have verified that r equals 6 and r equals 8 is in fact the correct solution to this problem.